Hey, good morning, everyone. This is section 5.6, solve rational equations. All right, so pretty much up to this point, what we've been doing is we took care of working with expressions that were rational, whether it was adding and subtracting them, simplifying, multiplying, and divide. Okay, so now the last section to close out chapter 5 is to be solve rational equations. Okay, so what I want to kind of bring back into your train of thought is this idea of proportions, right? So let's say we had x over 6 equals 2 over 7, and I asked you to go ahead and solve that, right? So what do you want to do in this particular equation? Well, you notice that it's fractions, and I'm sure you were taught since, about the 6th grade that you're going to want to cross multiply here. And that's how you start the process of solving your proportion. So x times 7 is 7x. And that's going to be equal to 6 times 2, which is 12. Now that you've cross-multiplied it, it becomes a linear equation. And then we can solve that really quickly. So x is going to be equal to 12 over 7. Right? So that would be your solution. So a lot of times, rational equations are in this form here. Okay? So we're actually going to look at those and mess around with a bunch. Now, the ones that are in proportion form are usually the easiest. There's some that are a little bit more difficult, and we'll get to those as well later on in this section. All right, here we go. Okay, so we have 3 different examples here, and we're going to look at each of them individually. I might be erasing some just to create some space here, but we're going to look at how we solve each of these. All right, so cross multiply, check our solutions. So here we're going to cross multiply. When we cross multiply, I am going to be taking the 3, and I'm going to be multiplying it by the x minus 7. Now, when I take 3 and I multiply by x minus 7, that's going to give me a 3x minus 21. Don't forget that the 3 has to multiply both the x and the 7. And that's going to be equal to, if I cross multiply the other direction, that's going to be a 5x times a 2. So that's going to be equal to 10x. Now notice very simply, it's just an equation that isn't too difficult. You're just going to solve it. So we'll subtract 3x to both sides. I'm going to get negative 21 equals 7x. Right, and then negative 3 is going to be equal to my x value. All right, so that's going to be my solution. Now, the reason why the problem says to check our solutions is because we have to be very careful, right? We cannot let this equal to 0, right? So if we let this or this one, because they're fractions, equal to 0, then that problem doesn't exist, right? So we call these things restrictions. So what's going to make my denominator on the left equal to 0? 0. So x cannot equal 0. That's one of my restrictions. In the second fraction, what cannot be plugged in? That's going to make my denominator equal 0. That's the number 7. 7 cannot be equal to 0. So as long as your answer is not one of the restrictions, then it's a solution to the problem. Okay? So when they say check it, just make sure that it doesn't make your denominators equal to 0, and I think you're perfectly fine as long as the algebra was done correctly. All right, let's look at this next problem here. Again, we're going to cross multiply negative 4 times x minus 3, and we're also going to cross multiply x plus 3 and 5. All right, so that's going to give me negative 4x plus 12 equals 5x plus 15. Okay, so we're going to get 12 equals 9x plus 15. Negative 3 equals 9x. Negative 3 over 9 is equal to x. And that's going to just simplify to negative 1 over 3. All right, so negative 1 over 3 is going to be the value of x that we're going to have for our solution. And again, just double check what's going to make my denominator equal to 0 here. My first fraction, if I make x equal negative 3, I get 0, so that's one of my restrictions. The other restriction is x cannot equal 3. So those are the only 2 restrictions I have, but it's negative 1/3. So negative 1/3 is actually going to be a solution that we can actually use. Okay, so let's take a look at the last one here. Oh boy, here we go. 2-finger touching is not my best here. There we go. All right, so same idea here. We want to cross multiply. All right, so we're going to get 11x plus 8 equals 2x squared plus 5x. Now, here's more of an Algebra 2 level problem where you have a quadratic as your result. So we have to get everything over to one side. So set the side equal to 0. That's going to give me 2x squared. When I subtract 11x, I get negative 6x. And when I subtract a, I get negative 8. So this is what we're going to have to go ahead and solve. Now, there is a GCF. The GCF is 2. So that's going to give me 2 times x squared minus 3x minus 4. That's going to factor into what two factors? We have x minus 4 and x plus 1. So what are the two solutions? The first solution for the first linear factor here is x equals 4, and the second one is x equals negative 1. Okay, and then we just have to compare that to our restrictions here. All right, so if I set this here equal to 0 and I solve, I'm actually going to get x equals negative 5 halves. All right, and if I do the same thing here, I'm going to get x equals negative 8 over 11. Those are the only two numbers that my answer cannot equal because it will make my denominator equal to 0. So both of these solutions check out. All right, so you can have multiple solutions for these. That's something that's not new. We've had multiple solutions for different types of equations throughout the year. But this is one where we definitely had to use factoring. Okay, so again, you've been factoring when you were simplifying and multiplying and dividing. So nothing new here, okay? Again, it's set up as a proportion, so just cross multiply and you're good to go. All right. Now we do want to look at some examples that don't use a proportion setup, right? Proportion setup is usually a fraction equals another fraction, but as we can see already here, okay, we actually have the sum of two fractions on the left-hand side. All right. Now the instructions say to use the least common denominator to solve each equation. All right, so we're going to do each individual one here, and we're going to see what that looks like, why we need to do it, okay? And I'm going to show you exactly how to do it. It shouldn't be a hard process, is as long as we know how to find the least common denominator here. Okay, so let's look at this first one. So I don't have a common denominator, but I know for my first one, the least common denominator is going to be 2 and the x minus 1. If we combine those two, we get the LCD. That's going to be what we're going to use to help us simplify my fractions here. Okay, so what we're going to do is actually we're going to take our equation and multiply each part by the LCD. Okay, so notice I took the LCD and I multiplied each of the three fractions here. Okay, and then what that's going to do for us is going to be nice and lovely. You're actually going to have a lot of cancellation here. Okay, what's going to cancel in this first fraction? The 2's. What's going to cancel in this second fraction? We have the x minus 1's. What's going to cancel in this last fraction? The x minus 1's. So now notice, because we multiplied by the LCD, every single denominator just got eliminated. So that's something good for us. So now we no longer have those complex denominators. So we're just going to have here, okay, 3 times x minus 1. So that's 3x minus 3. Here, all I have is 4 times 2. So that's going to be plus 8 equals x plus 1 times 2. So that's going to be 2x plus 2. No more fraction. Fractions are all gone. So now all we have to do is solve. So this is going to be 3x plus 5 equals 2x plus 2. We're going to subtract the 2x. That's going to give me x plus 5 equals 2. And then we get x equals negative 3. So negative 3 is going to be our solution. Again, like before, you want to determine your restrictions. This doesn't give us a restriction. X minus 1 gives us a restriction of x equals 1, and this is the same restriction. So the only answer we cannot have is x minus 1, but we got x equals negative 3, so that checks out. Okay, so there's your solution, okay, for the first example. All right, so now what I'm going to do is I'm going to clear this stuff out, and we're going to work on the second one here. All right, so let's find an eraser, and let's erase this example, because we are now going to be working on example number 2. Okay, so what do you think is going to be the LCD for the second example? Well, if you said 2x times x plus 1, that's correct. Okay, so we're going to take that, we're going to multiply each of the 3 fractions by this 2x times x minus 1. So the first part here, we have 3x over x plus 1 times 2x x plus 1 minus 5 over 2x times 2x x plus 1 equals 3 over 2x times 2x x plus 1. Again, we want to multiply by the LCD throughout. Okay, so there's your LCDs for each of the 3 fractions. Okay, once you do that, again, we want to simplify the fractions based on what's common. So x plus 1 here cancels. The 2x's are going to cancel for us, and then here the 2x's are going to cancel for us. So just like that, all our denominators are eliminated. So now what do we get here? We have 3x times 2x. That's 6x squared. Minus 5 times x plus 1. You're going to have a 5x. And you're going to have plus 5 equals 3x plus 3. 6x squared minus 5x minus 5 equals 3x plus 3. It's a quadratic. We have to get everything over to one side. So that's going to give me 6x squared minus 8x minus 8 equals 0. Now we need to start the factoring process. So what's the GCF? The GCF is 2, so that's going to be 2 times 3x squared minus 4x minus 4 equals 0. Okay, this is going to use a little bit of the asterisk. Okay, so I'm going to zoom out just quite a bit, set up the asterisk. So we have 3, negative 4. 3 times negative 4 is negative 12. So the 2 factors we're looking for are negative 6 and positive 2. This simplifies to 1 over negative 2. Sorry. 1 over negative 2. So 1 over negative 2 is going to be a 1 factor, and this is our other factor. So we get 2 times x minus 2, 3x plus 2. So x is equal to 2. And x is equal to negative 2/3. All right, so those are our 2 solutions. Again, come back up here, check our restrictions, make sure we are okay. X cannot equal negative 1 for the first one. For the second one, x cannot equal 0. Same thing with the last one. So as long as it's not those 2 numbers, we are okay. So that checks out and that checks out. So those are the 2 solutions for this one. Okay, now if you feel comfortable with this, I want you to try the third one on your own. Pause the video, see how you do it. Okay, if you need to see the third one and follow along, then by all means you can. Again, it's a video, so you can pause me at any moment in time, replay, go back to see if you didn't hear anything correctly. So let's go ahead and erase what we have here. All right, the last one. Finding the LCD is what's important. So the LCD for this one here is just going to be x minus 2. Okay, that's what we're going to multiply each of them by. This denominator for the 7 is 1, so again, we don't really need anything else, so it's just x minus 2. So we have 5x, x minus 2 times the LCD of x minus 2 equals 7 times x minus 2. Plus 10 over x minus 2 times x minus 2. Again, we want the LCD to multiply throughout. Again, if you need to set a parentheses here, just to show that you have to remember to distribute, you can do that. Okay, so again, we want to cancel out anything that's common. There's no denominator there now, and there's no denominator here now. So what do we get? We get 5x equals 7x minus 14 plus 10. Now we need to solve. So we get negative 2x equals negative 4. X is equal to 2. All right, so we got a solution. Okay, again, let's go back and check our result. X cannot equal 2. That's the restriction. But what did we get as an answer here? We got x is 2. So if it can't equal 2 because it's going to make it a 0 in the denominator, then we can't use this 2. Since this is the only solution and we can't use it, my final answer is that this problem has no solution, because that denominator is going to be 0, which makes it an undefined expression. Okay, all right, so that's all it is to solving rational equations. You have the two cases. You have cross multiplying, and then simplifying your fractions using the least common denominator. Okay, that's pretty much it. Okay, so hopefully this video was very informative for you guys. If you have questions, please don't be afraid to leave one on the Google Classroom stream or send me an email. All right, I'll be happy to help. Okay, hopefully everyone is safe and healthy. Again, I am holding on to the little hope we have to going back to school, because I do miss you guys, and I hope to see you guys very soon. Hope this video worked out, and thank you.